To use the LED screen, we have to make sure about this. The LED screen works also with rows and columns. So to make sure, we have the data chip here on the side, and these are the rows, these are the columns. Since we're going to plug it this way, you have to keep in mind that for the system, these are the rows and these are the columns. So I'm going to plug it here. And the LED screen requires positive and negative, which are already connected here by black and red. GND goes to GND, which is the second one here. VCC goes to the first pin here. So I'm going to connect them with the ones that are on the breadboard. Negative to negative, positive to positive. And then we have a couple more pins. We have DIN, which in the case of the code goes to the number 12. That means that the third one here, DIN, goes to 12. Then we have CLK to 11 and CS to 10. So I'm going to connect CS, that goes to 10, with this yellow jumper. This one goes to 10. And finally, CLK, which according to the code goes to 11. So here we have the LED screen, positive, negative, and the three signals goes to 12, 10, and 11. Okay, to control the LED matrix, to control the LED screen, the first thing we need is to download a library. The name of the library is LED Control. As simple as any library, you Google it as LED Control Arduino library or something like that, and you're going to find it. After you find it, make sure to download the zip file. You go to Program, include Library, and all the way up at zip library. You, on the pop-up screen, select the library that you just downloaded, and then again Program, include Library, and when you scroll all the way down, you're going to find here the library LED Control. Once you click on it here, you're going to see it in a different color, which means that it was properly included, different color this. Now, we have another library, which is binary, but binary is something you don't have to download. You just have to type it, just like you see it here, and automatically the Arduino program will recognize that you're going to use binary code to control something, in this case, the screen. You need to write this code. The instruction is LED control, LM will be the name of my screen. This is an object, the name of my object will be LM, and in this case the instruction will be LED control, the name of my object, which is whatever I decide it will be. Then I'm going to say equals to LED control, and I need 4 parameters. 4 parameters, 12, 11, and 10, because I am connecting the pins in the Arduino to 12, 11, and 10. And the number 1 is because I'm using only one object. You can control up to 8 different matrix with one Arduino, so which is pretty cool, because you only need to create 8 different objects, and that's it. So this is something you must write every single time. Then here on void setup, this is something you also I recommend you to write it every single time, so the screen will start properly. In this case, LM, because it's the name of my object, the instruction is shut down. The number 0 is because the counter in the program starts with 0. The people who programmed this library determined that the counters will start on 0. It's something that is just like that because they did it that way. So always number 0, and I'm gonna say false. Since it is shut down and it is false, that means turn the matrix on. In this case, second instruction will be LM because it's the name of my object, set intensity, and intensity, number 0 because is the object number 0, and the intensity will be set to 1. You can set intensity with values between 0 and 15, where 0 is pretty dimmed and 15 is really bright. And the third instruction is LM because it's the name of my object, that clear display, which is an instruction to turn off all the LEDs, clear the display, and 0 because is the number of my object. LM is the number 0 once again. Then after you write these 3 instructions, you can start programming. In this case, I am only showing one image, and the way to program it is having in mind if I am programming columns or rows. So the instruction will be LM because it's the name of my object, that the method, or the method, and the method in this case is set column. Set column, depending on the way you have the screen in your device, whatever device. As you saw when we created the circuit with the Arduino, I'm not using the columns as they should be used. That's the reason why I need columns in this case. Then in the parentheses, the first parameter I need is the number 0 because it's the number of my object, and then 7 because it's the number of my column, as I explained in the other video, in the previous video. Then the instruction B is because it is a binary, so you need to type that B, and since we have 8 different LEDs on each column, and I want all these LEDs to be turned off, I'm going to write 8 times the number 0, and then I finish the instruction. As you see, or as you saw, the LED matrix has exactly 8 columns and 8 rows. For that reason, you can see here that I have 8 different instructions, and they are numbered starting on 0, 1, 2, 3, 4, 5, until 7, in order. If you take a look to the code here, you can understand what will be the drawing that I'm going to make on the LED screen. Is like a heart. Number 1 means that the LED will be turned on, and number 0 means that the LED will be turned off. And that's pretty much it. You can design whatever you want here, but making sure that always you have 8 numbers between the B and the end of the parentheses. If you don't have the 8 numbers, most probably you're going to, the Arduino is going to get confused because it will have no idea what to do with that missing LED. And then I'm saying here delay 3000, but it will be, this will happen one time. It will wait 3000 seconds, 3 seconds, sorry, and then it will happen again and again and again because I only have one image. So if you want to use more images, basically you have to do exactly the same, but put it below. That's pretty much it. We're going to take a look to how it looks. And this is the program working. It shows the image of a heart. If I restart the code in the Arduino, automatically it will show the image that we programmed.